Couple. A couple consists of a pair of two forces which has the following properties: equal magnitude and opposite in direction, and act along the parallel lines of action. Here you can see two equal and unlike parallel non-collinear forces form a couple. Here you can see separated by a distance, perpendicular distance d, known as arm of the couple. A couple is shown in the figure. You could see here. This is the couple. You could see the force and equal magnitude, opposite direction, and along the parallel lines of action. They are separated by a perpendicular distance d. This is known as the arm of the couple. Two equal, unlike parallel, non-collinear forces. These two are not collinear. Since the two forces cancels out each other, giving zero resultant, a couple produces purely rotational effect in the body without translational motion. A couple cannot be balanced by a single force, but it can be balanced by only by another couple of opposite in nature. Moment of a couple. Here you can see in this figure, P is the force and D is the arm between these forces. Consider a couple as shown in this a moment of a couple about point A. Moment of a couple about point A is MA is nothing but P into D2. Then clockwise moment P into D1, that's minus P into D1. So MA will be P into D2 minus D1. So from this figure we know D2 minus D1 is nothing but D. So MA will be P times D. Now consider a point B at a distance d by 2 from force P. The moment of couple about point B is this P into d by 2 and this P into d by 2. Both are anti-clockwise moments. That's why these two are added together. So if you take the P into d by 2 plus d by 2 is nothing but d. So MB, moment over point B, is also P times d. So the moment of a couple is the product of magnitude of one of the forces and arm of the couple. So moment is nothing but magnitude of one of the forces and arm of the couple. From the above, we can see that the moment of a couple at any pivot point is P times D. It is important to note here that a couple does not have a moment center like moment of force. A couple has the same moment about all points on a body. This couple has the same moment at all points on the body. This is the important property, we need to remember it. Force couple system. The concept of couple is useful in application of parallel transfer of a force. Here you could see in this figure. Refer to this figure 1.16. Consider a force P is acting at the point A and is required to transfer from point A to B without changing its magnitude and direction. Now we apply two forces of equal and opposite. Their magnitude are same as that of force P acting at a point B and opposite direction at point B, as shown in this figure 1.17. Observing figure 1.17, we can see that two forces are acting in opposite direction at point A and B, form a couple, and moment of this couple is P times D anti-clockwise. Right. So thus, to shift a force to a point B, a couple is required to be added to the system. This system, which consisting a force and the couple at point B, are shown in here. This is known as force couple system. So we can transfer a force parallel to itself at any other point with the force coupled system. It also possible to replace the force coupled system into a single force by following exactly the reverse procedure as we discussed above. Equivalent systems of forces. Two force systems that produce the same external effects on a rigid body are said to be equivalent. That is, the sums of the forces and sums of the moments about a point are equal. Equivalent system consists of a single resultant force R through a given point and a single resultant moment. Two systems are equivalent only when the sum of the forces in the system 1 is equal to sum of the forces in system 2, and the sum of moments about any point O in system 1 is equal to sum of moments about same point O in system 2. Two forces 20 Newton, 25 Newton are acting at a point with an angle of 60 degrees between them. Find the magnitude and direction of resultant. This is the example we are going to look at it. Here P1 is 20 Newton, P2 is 25 Newton and theta is 60 degree. As we know from parallelogram law of forces, R is square root of P1 squared plus P2 squared plus 2P1 P2 cos theta. So we can get 20, 25 squared. If we substitute P1 and P2 in this one, we will get R is 39.05. That's the magnitude of resultant. And now we know that tan alpha is nothing but P2 sin theta divided by P1 plus P2 cos theta. Once we substitute these values, P1 and P2 and theta, we are getting the alpha as 33.66 degree. Now, disabled automobile is pulled using ropes subject to two forces as shown in figure. Determine the magnitude and direction of the resultant. Here you can see this is a disabled automobile and is using ropes subjected to the two forces. So here you can see P1 4 kN, P2 8 kN, theta is 55 degree. So we know resultant force from parallelogram law of forces. R is square root of P1 square plus P2 square plus 2P1 P2 cos theta. So once we substitute P1, P2 and theta value, we are getting the R value is 10.8 kN. Then similarly, we know from parallelogram law of forces, tan alpha P2 into sin theta is P1 plus P2 cos theta, right? So we can get the alpha value as 32.49.